it's actually something we started to talk about on that failed recording, which is that where it's come from is, as I've been working on this packages page update for Swift.org, it's made me think a lot about how we pick and recommend and discuss packages. And there was a bit in that failed recording where we talked about a package, and I ended up talking myself out of recommending it halfway through. And
well, you talked yourself out of it. You immediately said you shouldn't be using it. I mean, you didn't give yourself much of a chance, to be honest.
Yeah. And afterwards, we were discussing the failed episode, and you said it was a bit of a shame that got lost because...
yeah.
because it is actually an interesting thing. Like, there's value in talking about things that you wouldn't automatically... Like, a recommendation is a funny thing, because a recommendation... It almost makes no sense, because what might fit my use case might not fit your use case, and it might not fit everybody's use case, but there will be some people who find something in everything, right? So recommendations are a little odd in that way. But also there's value, I think, in talking about things that you wouldn't necessarily use, and there's still value in that. And it's something I've been thinking about, like I say, over the last... few weeks as I've been putting the final touches on the packages page, and that process that we're going to put in of people suggesting packages to recommend, and then having a kind of editorial process of picking some packages to feature on Swift.org temporarily, and that they shouldn't be pitched as like, these are the best packages ever. It's just, here are some packages. They may do interesting things. They may do interesting things and not be for you. They may be something that you can learn something from or get inspiration from, or there's many, many reasons to look at a package.
Yeah, absolutely. Yeah, I agree. And you can learn something from having a package discussed that is clearly not your use case, but still it's valuable in knowing that's just not right for me. It's too big for me. It doesn't do it quite the way I would need it. It's too complex because of the trade-offs it makes. Lots of things are just trade-offs, right? There isn't the perfect package, because the perfect package is effectively almost, often something you would have to write yourself, because that's the only way to guarantee it's actually tailored to your requirements. I mean,
Can I suggest Foundation?
Yeah, but is that a package in the sense that, I mean, obviously at some point it'll be a package in the, although actually that's a great point, because many people will argue Foundation isn't a good choice for what they're doing. They might be on resource constrained devices.
Sure.
Many Linux folks say, well, I don't want to pull Foundation in because it makes my binary bigger.
Yep.
Compile times are bigger. That sort of thing. Well, compile times isn't going to be an issue if it's a library like that. But once it's a package, that'll have an effect. Although I think on Linux, it is even part of its Swift core foundation is binary. I'm not 100% sure. But either way, you'll bloat your binary. You have more complexity if you pull in a dependency like that. And in other cases, it's the... Of course, you're going to import Foundation, because when you're building an app, there's so much you need. You'll eventually codable, all that stuff. You need Foundation. That's almost unavoidable. So, but it is a trade-off. Not every environment is the same. Not every system is the same. For some people, it's a natural thing to pull in. For others, it's the last thing they want to touch.
Yeah, it's a complicated subject to talk about, because you don't want to, or certainly I don't want to ever upset anyone if I talk about somebody's open source work here and end up even implicitly like saying, well, I wouldn't use it, then I don't want to upset anyone, and that has the potential to upset someone. But I think that discussion is really valuable. Maybe we should just not call them recommendations, because that implies some degree of experience or testing or usage of a package that you're saying, well, I've used this and I therefore recommend it, which is certainly not what I do when we look through these packages. I skim the packages, I look at the ones that look interesting, and then we talk about them.
Yeah, my process is a bit different, but I think that's also valuable that we don't do it the same way, because that leads us to pick different packages for different reasons.
Are you saying you test every package you recommend?
I actually do, yes. just today, my pick today, I tried it. I found a bug. I reported it. It's already been fixed. There's a new release. but I feel like, I mean, that isn't always the case, but most of the time I pick packages that I'm really curious about. And that curiosity is, part of that curiosity is trying it out. And that's why I often mention that stuff works in trying a playground, because that's how I try it. That's the easiest way to try it. And that's a huge help in trying them. But today's package, that didn't work. And I created a little package, which actually I realized I do in a complicated way. So what I normally do is create a directory in terminal, the Swift package init, type executable, type library. Actually, today I just did an Xcode project new package. It's so much easier. It sets everything up that I had to fiddle around with, and it's immediately there in Xcode. I sometimes you have these trodden paths you keep going down, and you never reevaluate what you're actually doing. But yes, I often do try it because I'm interested in those aspects of it. How does it actually work? And that's later on. That's actually a big part of what I want to highlight in that package. How does that actually work? I was really curious about that. And that's often the case. Not always, but often I want to see how it actually works in practice.
Well, now you're making me feel terrible and look like an amateur.
Well, which is exactly why I brought it up.
I'm not saying, although I did notice that halfway through your thing there, you said at the beginning, you said I test all packages, and then halfway through it switched to off. And so, no, I'm not saying that I don't test any packages, but it's certainly, in fact, I can give you a little preview. None of my packages that I'm going to talk about today, I haven't tested any of them.
Shame on you.
Shame on me, absolutely, yeah.
Well, I think the ones that I don't test explicitly are often ones I have used in the past. I'd have to check. I mean, I'm sure there's been one or the other where I picked it for other reasons and I didn't actually run it. But
you get a gold star, then I will get one printed and sent to you.
Excellent. What material is it going to be? Is it like valuable metal or something? Is it an Apple-like trophy?
Oh, Apple-like, yeah, okay. We'll give you one of those little pins that Apple
little, there we have it. Little is the value of my work. Right, but I think that's interesting, though. I think that's definitely an interesting discussion to have about what would be alternative labels for, instead of recommendations, highlights.
Yeah, we've been talking about this with that pull request, and the word that we've settled on there, which I quite like, is showcase.
Oh, right, yeah, it's a show. Yeah, that's good. I think that's really good, because that implies it doesn't have to be ready. A showcase is often a prototype or a proof of concept or just something interesting. I think that's good. Yeah.
It can be a preview. It can be, it's like, here is a selection of things that might be interesting.
Yeah. No, I like that. Yeah, I didn't remember what the final version actually was. Yeah.
And we've also been talking this week about a blog post, right?
Yes, we have. And that's a really interesting blog post that we came across. It's called Worrying About the NPM Ecosystem. And it's a blog post by Sam Blackley. It's actually quite old in internet terms. So this is 3 years old, from June 29th, 2020. And this is really interesting for us in particular, working on the Swift ecosystem and creating a package index on the ecosystem. Because what Sam has done is analyze the NPM ecosystem through the lens of what packages there are, statistics of the package index. And that's really interesting. I mean, obviously, there are many things that are different between NPM and Swift, size being probably the most critical part of it.
Well, it did strike me actually as I was reading through it again before today's recording. One of the so first of all, actually, I think it's really nice to see somebody step back and look at a package ecosystem like this for the long term. And we've got lots of history to look back on. You know, this is the Swift package ecosystem is obviously something that we're both very intimately connected with and passionate about, but there have been a great many package ecosystems to learn from, NPM being one, of course, but even back before then, you know, CPAN and lots and lots of package ecosystems. And it's really nice to see somebody taking a long-term look at, like, well, what are the problems? How is the reality of this ecosystem compared to an expectation?
Yeah.
And it did strike me as I was rereading it that maybe we should put a limit on the number of packages in the package ecosystem. So, you know, once that 50,000th package is in, that's it, we're full.
Yeah, some old ones need to go.
That's right. Yeah, something. You know, it's not that it can never change. And I'm not really being serious about this, but there is actually an interesting point to be at least considered of, like, is there a point where a package ecosystem, once it goes over a certain point, these problems are unavoidable?
I think so to some degree, but also there's inevitably a layer of cruft that'll accumulate over time. I mean, we see this already, right? There are packages that are effectively unmaintained and have been unmaintained for years and years and years. They probably don't even compile on any of the versions that we test. You know, they stopped with Swift 4.2 or something like that. I'm sure there are some that we just ended up with. And, you know, there's no process by which we would go through and drop them. So we'll carry them forward probably forever. I mean, unless we decide at some point, right, this isn't passing any compatibility checks, never has or hasn't in the last X years. Is that a reason to drop it? I don't know. Is it? What's the rule?
It's a good question that I don't really have a good answer for. But also, we're in actually a much better position than we really should be, because there was a point, and I can't remember which Swift version it was. There was a point where we just had to say that anything 3 and below just had to go. Like, even though there was package manager support for those, they were so old and it just didn't work anymore. So we kind of had a reset at around Swift 4, I think.
I believe package dump failed to work on very old packages, yes, or something like that. And package dump really is central to how we gather the very basic metadata for a package. So if that fails, there's really very little to glean from a package. That might have been the reason. Yeah.
And so we had that reset, and you're right that there are definitely packages in there that are so old that they don't compile on any of the versions that we test with, and will probably never be updated again.
Yeah, and what's to happen with them? And I mean, you can imagine NPM is going to have a lot of that. I mean, how old is NPM? Like the
tens of thousands. Yeah. NPM is I don't know, 10, 15 years old.
I mean, so in many regards, it's a glimpse of the future of the Swift package ecosystem. To some degree, I'm not sure size-wise it's ever going to approach anything like it. We should mention, like in the blog post, Sam lists 1.3 million packages in the NPM ecosystem, which is obviously more than 2 orders of magnitude more than we track right now, which is 6,000 packages and a few, which I guess we're also not tracking all of them. I mean, clearly we're not, because those are just the open source ones, which is also true for NPM, but we also are, probably much less established as the source where everyone goes to register the new packages. That's probably more true for NPM than it is for Swift Package Index. So that's certainly a difference. I mean, the size is just, imagine 2 orders of magnitude what that changes. And there are some other interesting aspects that he lists that he looked at that I found really quite surprising. So he looked at a thing, circular dependencies of packages, and that is something I did not really expect. So there are 1,700 packages that are directly dependent on themselves.
Yes.
Which I can't quite grasp how that works.
Well, he even says in his post, he says, they depend directly on themselves, either perfectly circularly or a different version of the same package. I have no explanation for that.
I can't. So the other example I can understand is like 2,500 packages depend on themselves via 2 steps, and he gives an example that is quite. Well, it's still strange, but at least it makes a little more sense how it could happen. There's Babel core that depends on Babel register, and that again depends on Babel core. But given that they're all, related to Babel, you'd think, how would you build a dependency tree where that can actually happen? I found that really strange. I wonder if there's something particular about NPM that makes that possible. So we should say that the blog post is also interesting for us because we want to do some of the same analysis for the Swift ecosystem soon. We're not in a position right now to do it because we're not actually gathering all the underlying information yet that we would be able to make that same analysis. But I'm really curious if that can actually happen.
I think part of this is actually a little bit specific to JavaScript, the language. We talked about Foundation earlier, and JavaScript is a very, very lightweight language and doesn't have anything like Foundation. And so part of the reason there are 1.3 million packages is that 100 people have all tried to solve all the basic problems, and they've all put a package out for all the basic problems. And and those packages get deeply, deeply ingrained in those dependency graphs. And I think that's a lot of these circular references are caused, at least in part, by that problem.
Yeah, that's actually in one of my first notes about what are potential lessons. How it's
sorry for sniping you.
I think that's really it, because a lot of the analysis that Sam is doing is highlighting his surprise at how deep the dependency trees are and how wide they are. So how many dependencies get pulled in. There's many packages that have 250 dependencies, and no, actually 2,500 dependencies is the maximum, and I think
2,500 dependencies.
2,500, yes, yeah. Sorry, I was quoting from crates from Rust comparison. So there's very 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 deep dependency trees, and I thought about how or why that is, and I think you're exactly right. That's why what I thought as well. A strong and good standard library probably trims that tree by a lot, because it literally prunes the tree of all these packages that other ecosystems don't need. And I think the other one is UI libraries that are practically always OS libraries that aren't part of the Swift ecosystem per se. Like we're not tracking Swift UI as a package that has sub dependencies or anything like it. UIKit equally. That's all platform libraries, which NPM really doesn't have, right? Any web framework, and there are lots of them, needs to ship all this as a dependency, right? That you then pull in and use. I think an area where you see the same issue is web development, and we are actually that's interesting. The SPI server package is the package with the most dependencies, and it's 56, and that's mostly Vapor and Friends, because that's a very rich framework with lots of dependencies.
Mm-hmm.
Vapor has everything nicely broken down into individual things, and like if you use a database, you by nature use the foundational Postgres library. Then I think there's even a separate one for the Neo stuff, and then there's a Fluent layer, and I think so have at least 3, maybe 4 database libraries that you pull in when you use Postgres as the database in Vapor, and that is the case for quite a number of other packages. I should also add, in our defense, those 56 includes dev dependencies, so it's not entirely that bad in the shipping binary. But I think we are sort of an example of a more typical NPM package in that sense, in that a lot of stuff isn't OS library stuff. I mean, I'm not even sure I think the Postgres stuff might need libraries. I need to check what we actually need in our Docker image, but a lot of the stuff we build to run is very foundational in the sense there's very little that the OS actually provides as underlying libraries that get used. A lot of it is just straight up code that is built on purpose to provide the functionality itself. What I also found interesting, and I'm not sure if you followed that link, there was a follow-up post where Sam looks at the same analysis for Rust, and that was quite interesting. Did you see that one as well?
As I skimmed that one, but I didn't read it in full depth.
Yeah, it's a bit interesting, and in particular for our case, because it's sort of in between. So Rust at the time, this was July 2020, had 50,000 packages. So we're just an order of magnitude away now from us.
Yeah.
It also includes cycles, dependency cycles. So that might indicate that it's just something that happens.
This is the ghost of Christmas future.
Yeah. And a lot fewer dependencies. And I think that is to our point that a strong standard library probably prunes that tree quite a bit. And he mentioned that, Sam, that it's very likely due to a few very popular packages with few dependencies that early on caught on and sort of were crystallization points for all the work. And I think Swift is a good position, like especially with many of the packages in backend development and Swift server group SSWG packages. Swift Neo, for instance, is taking care of a lot of the plumbing in terms of networking, where Swift benefits from having packages in lots of areas, but not multiple different implementations. So there's typically one good library that does it, and all the effort to maintain it is focused on that one library, and then it gets used a lot and battle tested, and sort of often they have good dependency trees in the sense that there are few dependencies that they themselves have, or it's the same ones again and again. So I think all of this helps a bit in keeping this growth in check. But obviously it's going to be interesting to see if that changes and how that changes as the index, the ecosystem grows.
It will certainly be something we have to keep an eye on. While you were just talking then, I had a suspicion, and I just double checked it, so we have actually two dependency trees in SPI server. As you say, our Swift dependency tree is quite large because of Vapor and the database dependencies that we bring in through that.
Right.
We also have a JavaScript. Yes. We also have a JavaScript dependency tree because we have a front end process, and that has its own build process, and we use the standard JavaScript dependency manager that we've been talking about today. And I did pick our dependencies very carefully with the front end, and I've just double checked. We have 3 top level dependencies, and those dependencies have 0 second level dependencies.
Oh, nice! I was just sort of bracing myself for a big number there.
No, so it's actually we're the opposite. We're living in opposite world. Yeah.
Wow.
We do have. So I should just mention we do have a much bigger resolved file because in production we only have 3 dependencies, but our build environment gets into that whole messy NPM tree. So we have some development dependencies and we have some production dependencies, and our development dependencies are much messier than our production ones.
Right. Yeah, I need to check. I'm actually curious how many Swift production dependencies we actually have. I mean, it's not going to be a lot because we have snapshot testing and that sort of stuff, but I can't think of a lot of specific test dependencies that we're pulling in.
Sure. Mm-hmm. Well, that's an interesting look at the ecosystem. I would thoroughly recommend, obviously we'll put it in the show notes, but I would thoroughly recommend reading this blog post if you have even the slightest interest in what we've been talking about, because it's fascinating. well written. It'll make you laugh a couple of times. It's a great blog post.
Yeah, really good. And I'm curious. So we'll definitely endeavor to produce the same numbers, same statistics for the Swift package index. We're just not in a position to do that yet because we're not tracking the full dependency trees, but it is coming.
Well, I think it's also good that we're thinking about this while the package ecosystem is this size.
Yeah.
Because I think one of the ways that you stop it happening is by showing it happen.
Well, the question is, can you really? I mean, how?
Like we were saying earlier, I mean, I do believe there probably is a size at which this becomes inevitable. But certainly there are things, I think we're in pretty good shape to delay that inevitability at least a little bit.
Let's see how it goes.
So should we showcase some packages?
Let's showcase some packages.
You can kick us off this week.
All right, I'll kick us off. So my first package is actually 2 packages in a trench coat. And I do suspect one of them might appear in...
They depend on each other, right?
Actually, they do. But it's unidirectional. I suspect they might also be in iOS Dev Weekly later this week. But I'm calling first dibs. And it's from our good friends Point Free. It's Swift macro testing and Swift snapshot testing. Disclaimer, Point Free Co. are a sponsor of the Swift package index. But I just can't resist. I'll always recommend them. They're good packages, Brunt.
I saw both of these in the RSS feeds, and as soon as I saw them, I just skipped over them because I knew you'd pick them.
You left them for me, nice. Yeah, they're really great. What I love about them is that they are useful, but also useful in interesting new ways, and they really build on top of each other. So, right, let me explain what they do. So, the first one, Swift macro testing, is about macros, which is a new feature in Swift 5.9, and Swift 5.9 obviously comes with the ability to implement macros. It also has some facilities to actually test your implementation. And what it does effectively is it adds an assert macro expansion. And then you can inline, have a literal string that is your expectation of what it should look like and the macro definition itself. And then it compares that the macro expands into what you wanted it to expand to. And the package, Swift macro testing package, expands on that, no pun intended, by giving you more capabilities, because the assert macro expansion test, while nice, is fairly basic. So it only allows you to compare the strings, and you sort of have to manage that yourself. What their assert does is it actually puts the expanded expectation into your source code in line. So you don't need to prepare something and then copy paste it in. You write an assert with the macro definition in it, as you call it. Then you run the test. If you know how snapshot tests work, you normally run the test and then it writes out a file. And then you confirm, the file looks like as I expect. And then when you run it the next time and the file is there, it just compares the next snapshot against the file.
Right.
What it does here is it is not file-based, but it actually places the expansion into your source code in Xcode, and it uses Swift syntax under the hood to understand your test structure and does effectively a live source edit of Xcode. So it as if you were typing out the expectation itself. So that's quite nice because you don't need to fiddle with the expectation. And obviously, once you've done it the first time, it'll then, if it's different, it'll highlight a difference, right? It only does that if there's nothing there yet. So this is your first capture of the difference. And it goes beyond that because it doesn't just snapshot your expansion, it also snapshots diagnostics and fixits, which is something that the built-in assert macro expansion doesn't do. So this is only for testing the expansion itself, and Point Free Co's tool also allows you to test all the edge cases, like diagnostics when there's something wrong with your macro call, or fixits when you want to test what your suggestions are, how to fix issues with the macros. So that's quite nice. And this.
So I think because I did see the macro package fly past, but I didn't look into it in much detail yet. Like I say, I knew you would I knew you would take it. But what I did see was, I think, what you're about to talk about, which is the other side of this, which is an enhancement to Swift snapshot testing, which added support for inline testing this week. And even now I understand why they added that, but that feature, even on its own, is invaluable. We use snapshot testing in a couple of different ways. We have HTML snapshot testing, which takes fully rendered HTML files of hundreds and hundreds of lines of HTML and snapshots those, and those obviously suit file-based snapshot testing really well. But then we also have a whole load of other uses of snapshot testing, like we snapshot test some SQL queries, and we snapshot test even just a bit of like JSON, like a fragment of JSON somewhere, or even just a string, like we render a date or something, maybe we'll just snapshot test that. And currently all those live also on disk, which is, it's okay, it's not terrible, but I really liked the idea of being able to have those snapshots just inline in the code, and now finding out that they will automatically update if you ask them to. That's just the icing on the cake.
Yeah, that's really nice, because it's you always have to sort of make the decision. I mean, it still doesn't make sense to do an inline snapshot for hundreds of lines of output. That's clearly something you want to stick in a file,
of course.
But many smaller ones are just really nice to have inline, because you don't need to go hunting through the file system to actually look at the snippet, right? It's really nice if a 3-liner, 4-liner is actually inline there in the test, and that's this amazing new feature of the inline testing. Not only that you can have it in there, but it actually automatically manages that representation inline, and you just effectively look at it. Yeah, looks all right, and run it. And then if it fails, it gives you the same message as if it was a file. And obviously also you can always see the diff in your source tree, even if you were to save it.
That's great. It sounds like a real enhancement to the snapshot testing library.
Really great couple of packages, and really nice combined release of those.
So my first completely untested and unexperimented with package is So it's the package is CloudKit Sync Monitor. So in order for me to have tested this, I would have had to set up a CloudKit project, and there's a lot of testing in that. It's by Grant Gruninger, and it monitors the state of an NS persistent CloudKit container synchronization process. So I think this, if it does what it says on the tin, which I'm sure it does, I think this is a package that potentially every CloudKit application should include, because one area where CloudKit is a little weak, certainly in the operating system and also in applications that use it, is feedback on what's happening with CloudKit Sync. Has it finished? Is it still going on? What's happening? Did it error? And this allows you to hook into all of the notifications sent out by the persistent CloudKit container, and translate them into some published properties that you can then monitor in SwiftUI and update some UI, or keep whatever tabs on it you would like in an easy way without having to subscribe to all those different notifications. And it doesn't come with any pre-built UI, as I believe it shouldn't. I think that's something that you should, each application should determine how to surface this information if they choose to. But it does kind of tame all those notifications and give you a nice way to just take a look at what's happening with your sync state. It's got a great README file. It's actually been in development for a couple of years, but I've not come across it before.
Nice. Yeah, I mean, that's super hard to test. Actually, as you were saying it, I realized I did not test the macro testing package. So there you go. It's immediately.
See, I knew it wasn't. I knew your virtue wasn't as complete as you claim.
But snapshot testing, I've tried.
Well, we've all used snapshot testing.
All right, we all have. Right. My second pick is called Lighter by Helge Hess. And this is a really interesting package. It's not new. I've known about it for a while, but there was a release in the last week or last couple of weeks, and this is the package I was alluding to earlier when I said I was curious about how it's actually implemented. So Lighter is a very interesting SQLite database access package. And this is probably an area where there are quite a few candidates in the package index that is well serviced. There's a rich field, like for instance, there's GRDB by Gwendal Rouet. That's probably the most widely known and used representative of the package, of a SQLite database access package. But Lighter is really interesting in its approach and its use case effectively. It is a package that source generates SQLite library bindings. And it can do that in two ways. One is just straight up a layer that directly interfaces with the C library. So it's dependency free, what you get out of it.
Mm-hmm.
And the other one is it generates an additional layer on top, which is a lighter layer. So it gives you a nicer high-level API to talk to your database. But what's really interesting is the marketing, if I can call it that, of the packages. It's really, really fast, and it has a performance test suite where it calls some numbers, so that are quite remarkable. So in some of the tests, it's 6 times faster than GRDB, and it's 3 times faster than GRDB if GRDB is sort of manually tweaked effectively by avoiding codable, which is apparently a very big price to pay there. So it is quite fast in the tests that Helge is running. But I was really curious about some of the things he's doing in his examples, because he has an example how you filter on a query. So, as you can imagine, you run a database, get me all the records from a table and filter, like a typical where clause. But it's written like a Swift filter with a closure. You have, for instance, I loaded up a music, there's a Chinook, I think it's called, a test SQLite database that you can download, which has sample data in it and has tracks, like music tracks in it. And you do db.tracks.filter, and then you pass in a closure where you can apply a filter on the tracks individually, right? You do $0 length, like the track length, and then I queried for all the tracks that are longer than 300 seconds. And that runs, obviously with the number of tracks in it, I wasn't able to tell if it's fast or anything, but I did actually check how it's implemented, and that was really interesting, because what it does, effectively, it binds the closure as a C function pointer to the SQLite library. So the library actually runs your closure directly, like as a function inside the database. It's as if in a Postgres database you had shipped your code as an extension and then called into it. You had all this done ahead of time, and then you were calling into it. It can actually do that with straight up Swift code. And I was really surprised that works. Obviously there's some unsafe pointer stuff going on to make that work, but that explains how that interface works and how the claims can be made that this works without having to translate all sorts of variants of Swift code into where clauses, right? That's not happening. It's actually just executing the predicate directly in C in the library, and that's remarkable. So yeah, it's a really interesting package. I tried it out with the Chinook database, works as advertised. It code generates, so there's a build plugin that comes with it that auto-generates your database access layer. You give it an input database, and it looks at the schema and pulls out all the stuff. And that worked fine for that database. Well, it worked fine, actually. That's the thing I pointed out earlier. There was a formatting issue in the underlying database, and that broke the generated code, and Helge fixed that really quick. And that's the one thing I had in my notes. When you adopt that sort of library that generates code, you there's a slightly bigger risk, that things might not go 100% if the code generation doesn't work, right? So you have a bit of an extra risk there in your dependency. On the other hand, if you don't regenerate, right, what you already have is going to keep working. So at least there's some safety there, but it's something to bear in mind for packages like this. But I believe if you need a really fast SQLite database access, and you don't want to deal with the C aspects of the SQLite database, which is the database library, which is probably not something you want to be doing, this looks like a really great option.
That's great. And I like how in the description of the package, it ends with dependency free. So it says Swift APIs for SQLite, type safe down to the schema, very, very fast, dependency free. I think, the fact that it's made it into the description of the package is obviously that's how important Helga is taking it there. Although I would argue it does have a dependency on SQLite. But I think we'll forgive him.
Well, on macOS and iOS and everywhere, the library's there. That's probably only on Linux where you.
So then we get into defining how do you define a dependency?
What's a dependency?
But let's not go down that route. So.
It depends.
Instead, we'll go back to my unresearched, untested list
You're really going to hammer on that one, aren't you?
Well, I was going to say, actually, this one, I haven't tested this version of it, but I have used this package in the past. It is shipping in the iOS Dev Jobs app, which uses SwiftUI Introspect by David Roman. And I have a feeling we've talked about this package on the podcast once before, right at the very beginning. Because I think I just finished using it in the app when we were looking for packages to talk about. And I think I talked about it then, but I'm going to mention it deliberately again because it's just hit a 1.0 milestone, which is always worth celebrating, especially for a package that is so good like this. What it does is it allows you to get at the underlying UIKit or AppKit controls underneath a SwiftUI view in a safe way so that you can, if there is something that the SwiftUI view doesn't quite do, it means you don't have to completely throw that SwiftUI view away. You can, if it is based on a UIKit or AppKit control behind the scenes, you can get access to that, modify whatever properties, call whatever methods you would like to on that object. And it does it in a safe way so that if the underlying implementation of SwiftUI changes, it does not crash your application. It just doesn't set those properties. Now, of course, if you do something in that code that you then 100% rely on later, that's your responsibility to make sure that if that code suddenly goes away, your application should still at least work. But this is a really great library for filling in those little gaps. And those gaps are getting less and less every year. There will be a happy day, and I'm sure David will agree with me that it will be a happy day when he can say, this library is no longer necessary. And there will definitely come that point. One of the things that I liked that has been added since I used the package, which is an opt-out by default to new versions. So when you introspect something, let's say you're looking for a scroll view inside the SwiftUI scroll view, you now have to say, I'm looking for it on iOS version 13, 14, 15, 16. And then if version 17 comes out like it just did, you would have to manually opt in. You could say, like, I've tested this on the new version, I've checked it, I'm going to add that additional case so that it enables my introspection on the new platform. Yeah, I think it's a great library. It supports, there's a huge list of controls that it supports, everything from page controls to scroll views to steppers to tables to all the different lists and grids and things like that. It supports an enormous amount of the SwiftUI API. It's been around for a long time. It's been around for 3 years now, which I think is pretty much as long as SwiftUI has been around. Wasn't SwiftUI's first year 2019, was it?
I think so, yeah. Isn't it Swift UI 3
Yeah, I think
that
so.
we're on or something? Well, if it's 2019, wouldn't it be 4? I don't know.
So yeah, we maybe it was a few months after SwiftUI first showed up, but it's certainly been around for the vast majority of SwiftUI's lifetime. And I can recommend this package because I have used it.
Nice.
And with that, I think we'll call it another episode, and we will be back with some more showcase packages next week and more news from the Swift Package Index. So we will speak to you in 2 weeks.
See you in 2 weeks. Bye-bye.
All right, bye-bye.